Hello everyone, you're on Maths with Daniel Dose. Today we're gonna go through functions. It's some more about conceptual way to describe functions in comparison with, plotting graphs, crunching numbers in order to get from x the value for y. So I just want to say that it's more about idea of black box when you have an input after a certain rule that function set up. In this case, you'll have a certain output. So we'll be speaking in this way, and I like this approach because it conceptually trying to deliver the right way of understanding what function is. And of course, we're gonna use lots of diagram for your better understanding. So this topic will be useful for GCSE, iGCSE students and also for A-level students if they're at the very beginning of their education in the first year, and that's the right time to get started. So as I said, the function works as a black box. Just have a look at this diagram. So you have an input, a certain value that you put in this black box. You have no idea what's going on inside, like certainly you have no idea how a computer works. That's a pretty complicated system, as well as, let's say, robots. You've seen robots from dynamics car operations. Yes, you know that. It's pretty complicated system. All right? But the black box set up a set of the rules or just one single rule that we denote as the function. So basically what we have inside, we have specific rules, and that rules is set up by the function. So function, all right? And we have certain output. So what you have as a result of the handling your input inside that black box. All right. So I just want to take a pretty intuitive way of how to understand how the function works. For example, you approach the coffee machine. All right. So you want to order some specific coffee, right? You need to specify first of all what kind of coffee you would like to get prepared. That machine works for you in this way. It needs to grab the order from you. All right, so you press the button, you choose a certain drink, let's say cappuccino drink or American coffee or normal espresso, and you also have another input, money input, right? So you need to put a certain value for a specific coffee, but it's, of course, it goes step by step, because the first step is to get the order from you of choosing the right and proper drink you want. After that, it defines the price for that. It's waiting for you. You put a certain amount of money in, right? And after that, the black box start working for you. So it gets prepared different process, of course, of cooking as a normal production process that you have probably in a plant, but in this case, it preparing coffee for you, certain drink that you've chosen. And as a result, there's going to be certain output. All right. So that's how normally function works. As you understand, there might be several inputs. So in the black box, there might be input 1, there might be input 2, and input 3, right? Let's denote as input 1, I2, and I3. But after handling those inputs, that's going to be the single output. So this output is going to be the single one. Of course, due to different inputs, for example, you've chosen espresso, output will correspond to the input. So that's sort of correlation. It always works like that. And you have, anyway, single output corresponding to inputs. In this case, you have input as making an order, right? So that's the first input, sort of choosing this type of the drink. And another one, it's going to be the input corresponding to money value, so sort of money inputs. And black box works is set up certain rules and operations. It's somehow actually trying to to handle your order so that to deliver you a certain output. All right, so hope you understand. The same idea is all about dialing a number. You just find a recipient, so you just press on your smartphone, and that's how you establish the call, right? Okay, So complicated system, there are rules. It's not just a single rule. There are several checks before your value get into the black box, and after that you'll see the output corresponding to your input. But of course it's not going to be proper if for some inputs there might be several outputs. I understand that you might say in the coffee machine there might be also outputs as the money value, right? It can gives you change, right? For example, you put let's say I don't know, for example, $1, and let's say normal espresso costs around like 50 cents. Of course you will get a change for that, but that means, for example, improper functioning of this coffee machine would be as if you order espresso and as output it can give you like espresso, let's say Americano, cappuccino, latte, several outputs. Of course, it's not normally functioning. So you may say that there is malfunction in your coffee machine, all right? So it's not proper functioning. So that means the key idea here is that you might have several inputs into the black box, but certainly after that, you need to get, you need to get after black box works, right? Performs sort of operation, you should have single output. That's how the function works. All right, so let's get into correlation between the real examples and what do you expect to have on your graphs and just on absolute mass. So you have an input, and that's might be any variable. So normally we understand that it's going to be x. That's how you actually stick to, right, on your math class. So black box set up the rule, what is called f from x. It means it set up the rule on your variable x as input. All right, so this rule might be 3 times x. Let's set up this simple rule. So you multiply by 3. So no matter which you have as an input, so you multiply by 3. So that's how the rule works. As the output, you'll get a value for y, which means, in our case, according to the rule, for input being multiplied by 3, you'll get 3x. And finally, you get the function y equals f from x equals 3x. So that's the mathematical expression for how the function works. So graphically, how we can do that? So no matter, because you're not limited for input, of course, so for some function, input might be restricted, but for this function, which is called linear function, so that's definitely linear function, you don't have any restriction on your x value. So that means x is any real, it might be any real number. We don't touch imaginary numbers. And as a result, you'll get y as output, also any real numbers. So that's called domain of the function, domain, and that's called range. All right? Get to know those words because key terms of your first education, especially on A level and IB program. All right, so now, because we're not limited, we're not restricted for the inputs, so we can plug any convenient numbers because that's linear dependency between x and y. So we can, we need to have just at most 2 points, that's enough. I'm amazed when people and students can answer the simple question, how many data value you need in order to plot the straight line. Because 2, that's enough. Just for more precision, of course, if you do it graphically, you can actually pick up more values, but that's all about just redundant check. Trust me. All right, so I've taken 0 and let's say I've taken 1. So corresponding according to the rule, fx will get 0. Obviously, it starts from the origin, and when it's 1, it's going to be 3. So you have correspondence 1, 2, 3. So that's another point. And you use the straight line to connect those 2 points. So that's how your function works. So this is visualization. So you visualize your graph fx on xy set. All right, hope you understand that. Remember about domain and range. The input might be restricted. Let's just consider the function if it works like square root of x. So of course, for input, you can consider only positive numbers and 0. So that means in this case your input is restricted, and as a result the range, because square root of any positive number or 0 is going to be more or equal to 0, so you also restrict your range. So make sure you understand and make sure you can differ like in different sort of functions, what sort of unexpected value you need to handle in order to have your function undefined. So in this case, if you plug negative number instead of x, you'll get obviously incorrect results. So basically your calculator cannot handle this operation. So in other words, it will throw you an error. In the system, if you ever seen how the program on computer program is arranged, so it's sort of commands, instructions, right? You can consider different functions, and functions works there pretty much the same as in math. So you have restricted value for your input. So now you just write in code how to handle errors, and after that, in case you input the wrong improper value, it needs to throw the program needs to throw an error, or at least a warning that it's not a proper value. That sort of checks. So before function, like in computer system, before how the function works, basically it goes through a list of checks, and after all checks completed successfully, it can evaluate the final result corresponding to your input. Right, so make sure you understand. That means here you're just working with absolute functions. However, just in reality, you'll have a real essence of those checks and what is called domain, and as a result for range. All right, hope you understand this idea. And what if we want to construct a composite function? All right, that's normally in different system, they consider not just simple input and output. They have basically compound functions or composite functions. For example, let's consider a function f. It works like input, some black box under certain rule f, and output. So if you consider several functions f, that's going to be the first function f, it will give you output, and that's going to be input, another one, function f. As you understand here, the output of the first function f on a certain rule f becomes the output for a certain value, for a certain function f becomes the input for the first handling. So that means the result of what function f delivers to you becomes an input again into the same function. So let's consider a simple rule. Again, function f works like multiply by 3, so every time. So that means for input x, it will deliver you the output y equals 3x. So what it means in this case, so if you have an input x, the output is going to be 3x, and that's output becomes an input. So your input, instead of your x, you need to put 3x. And because function works like you multiply by 3, so finally you'll get times 3 times 3x is going to be 9x. So that's how function, composite function works, all right? And that means the same as you write mathematically f from x, okay? So you first, starting from the very nested function f, so you have an input, that's going to be the first input 1, as in this case. The result of how function works becomes the output, but that's the whole expression becomes the input for your second function, second, say, chain of handling. So that means that's become the input 2. So that becomes input 2. All right. So that's how you can actually work out function from function from function. You understand what I mean? All right, so let's move here. That's the GCC word examples. So I've seen a similar one in paper that actually was in 2020, so several days ago. I was amazed that they decided to test this idea. So, these exams were pretty, let's say, non-standard and non-regular ones, so especially in paper 2. So that means you need to get ready to think more, more abstract level. So trust me, you need to get prepared, not just crunching numbers. You need to be pretty well diverse even for this problem. All right, so let's consider that quick. If you know how to do that, if you be based on portion of knowledge that I gave to you in previous part of our considerations, so I think you could be able to do that. But let's try to see my explanation. So here you have the rule, so input multiplied by 4, and the next one, on top of that, you need to add 3. That's going to be the output for the function. So basically, if you x as the input and y as output, write an algebraic expression for y in terms of x. So basically, you need to write how you can get y from x. So you set up the rule f from x, and that means, first of all, if your input is x, so you multiply by 4 is going to be 4x, that it becomes the input plus 3 for the next process plus 3, so on top of that you add 3, and the result output becomes the value y, okay? So that's, in terms of algebraic expression, it's going to be a straight line in this case, 4x plus 3. You can try to build that, the graph, to visualize what actually this rule tells you. So let's go to B. If number A is the input into function f, and output is also a, find a value for a. All right, so we've got in this process, we have a as the input, so instead of x, we just plug simply what we need to do. We need to say that y from a is simply what we have, 4 times a plus 3. And the result, that means output, becomes a again. So y from a becomes a. So that means we can equate 4a plus 3 to the result output to a. From here we can work out value a, so just I hope you understand how to work with repeated linear, with a linear equation with a repeated variable, or repeated unknown. So 4a minus a is going to be 3a, and you transfer 3 to the other side. That means it becomes negative 3 over 3, which is negative 1. Okay, that what sort of input you had in this question. Let's go to C. Here is the composite function shown on the diagram below that works according to the following diagram. Okay, so here is the composite function. So you have some input, that's function f that was described before or above, and that's again the output of the first function set up on the first step becomes the input for the second function. That works pretty much the same, means that's the same function. And here is the output. So if x is the input in this process and 100 is output, you need to find value for x. All right, so we've got inputs x. According to how a function works, we already got it on step A. It's 4x plus 3, so that's new input becomes here. And then you need to put this whole concept, this whole expression, instead of x. So you simply need to plug that instead of x again, because you already got the algebraic expression for this. So that means you've got 4 times, instead of x, you plug in that compound expression, and on top of that you add 3. So that means that's going to be output in that case, and you know that output is 100, so that means it's equal to 100. All right, so let's simplify that. It's going to be 16x plus 4 and 3, 12, and on top of that is 15. That means you have 16x equals 85. From there, x is going to be 85 over 16. All right. So I hope you understand how this works. And finally, what I want to tell you is the difference between a relation and a function. So you heard like function, 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 but on A level, you're gonna hear a new word, relation. Just right now, make sure you make clear difference. As you remember with our coffee machine, we discussed that for a function, there might be several inputs, but the idea after goes through the black box, BB black box. It will throw the definite or certain output. So here is going to be input and certain output. So this output becomes and should be single. That's how the function works. What about relation? For relation, in contrast, there might be several inputs or just single one, and after some rules applied, that becomes several outputs. So it will give you output 1, let's say output 2. Basically, the contrast is that it will throw you different or several outputs. So input 1, input 2. That's what is called relation. So this is relation in contrast to how function works. And I just want to depict you using a simple circle. So circle is a type of the curve, LOCI or LOCI set of points that are equidistant to some specific point, what is called center, the center of the circle O. This distance called the radius, right? That's how we can define a circle. But the circle centered in the origin should have an equation x squared plus y squared equals r squared. So in that case, 1, 2, 3, 4, 5, we know that the radius is going to be r squared, but in our case r squared becomes 5 squared, so that means it's going to be 25. So we have this, and now we need to decide, is it a function or is it a relation? All right, how to test it? The test is pretty much simple. What you need to do, you need to see that for a given value for x, let's say x equals 3. So we choose that random value, x equals 3, within, of course, the domain of the curve. So domain is from -5 to 5. That's all available status for x. And for x equals 3, because we fix this value, we put the vertical line. And you see that it will cross your circle in 2 points. So that means it will have a certain value for y, that's going to be y1, and another certain value, what is called y2. So if you just prolong that, so that becomes symmetrical value about the origin, which is y2. So obviously you can say that y2 becomes negative y1. All right. So if you like, you can plug this value in and just simply solve for y. So we'll get 3 squared is going to be 9, so y squared becomes 25 minus 9, right? 25 minus 9 becomes 16, and if you take the square root, you'll get plus minus 4. So that means y1 is going to be positive 4, and y2 becomes negative 4. All right, so we've got two values for y. But y in our case should be output. So if we consider how y from x dependent on, we understand that for specific x equals 3, we've got two outputs. So 4 and negative 4. So what it means, we actually have a deal with a relation. Basically, graphically means how we can test the curve is a relation, not a function. You just need to draw the vertical line when x value is fixed and see how many points of intersection you have. So for some function, you might have like in certain region for x, you might have just one intersection. For another region, for another part of the curve, you might have two. How to decide? Is it function or relation? So it means that relation is if it crosses twice, at least twice, that means it doesn't, it's not, specify in which region. So in the whole domain, if it's ever cross your curve at least twice, so that means your curve is described by using relation, not a function. Circle is the pure example of relation. All right. You can practice with parabola. Also try to put vertical test. It's called, by the way, vertical test, and that's how it can help you in order to differ relation from function. All right. So hope you like that. That was pretty interesting. So I just decided to use more conceptual way describing function. Hope I clarify this pretty interesting and very significant concept, function and difference relation. So both concepts are very useful in your first study, and hope you get it. Thank you. That was Daniel Dallas. See you next time.